Hello everyone, now we have to discuss the analysis of delta star connection, that is delta connected supply system and star connected load system. So this is the example, the line currents of a three-phase generator being 20 amperes. Okay, a star connected load is applied across the terminals of the generator having load impedance of 6 minus j8 ohms per phase. Right, first we have to get the connection diagram. Okay, delta connected supply system, these are the three-phase windings R, Y, P completed. Then coming to star connected load, we are having what? Right, that's it. This is R, this is Y, this is P. Then Y and then that's it, right? Given that the impedance per phase is what? This is 6 ohms, this is minus j8, right? Minus j8 means what? This is not inductor, this is what? Capacitor. Sorry, minus x, right? For capacitive impedance, what is that representation? Let us take, right? Here we have what? Capacitor, like that we have. Now it's clear, 6 minus j8, this is 6, this is minus j8, this is 6, this is minus j8, that is R minus jXE, series combination of resistance and capacitive reactance. Clear? And he given that the line currents of a system is 20 amperes in R phase, Y phase as well as B phase. Okay, therefore the system is balanced system. So this is the given data. You all know that in delta system, IL which is equals to root 3 I phase, VL is equals to V phase, like that. The star connection system, VL is equals to root 3 V phase, IL which is equals to I phase, that's it, right? As the load is star connected, the line currents will be phase currents of the connected load, right? See, as the load is star connected, the line currents will be phase currents of the connected load. Okay, that is, first we have to get phase currents, that is phase currents in star connector load is nothing but IR, which is equals to what? 20 at an angle 0, right? Like that, IY which is always displaced by 120 degrees of IR, amperes, and IB which is equals to what? 20 at an angle minus 240 amperes. That's it. This is about the phase currents, nothing but line currents in case of star connected load. Now we have to get the phase voltages of star. This is nothing but phase as well as line, right? Now we have to get phase voltages, right? Means what? VR, right, which is equals to, that is P phase, which is equals to I phase into Z phase, right, which is equals to 20 at an angle 0. Z phase is what? Which is equals to what? We have 6 minus J8, right? Before that we have to write that point. So where Z phase, which is equals to 6 minus J8, which is equals to what? 10 at an angle minus 53.13 ohms. That's it. So from this we have to get the phase voltages. In case of star connected load, what is the phase voltage? That is VR, which is equals to 20 IR at an angle 0 into 10 at an angle minus 53.13, which is equals to what? 200 at an angle minus 53.13. Here we have to write one important point. See, here the impedance is what? Negative, right? Negative value. For example, if the phase voltage is taken as reference at an angle 0, obviously the current leads, right? Because I phase equals to V by Z. Here the impedance is what? Minus 53.13. Therefore current is what? Plus 53.13. From this, therefore I phase leads V phase by 53.13 degrees, which is equals to what? 5. See, here what is the value of phase voltage? Which is equals to minus 53.13. Means what? Current is at an angle 0. Voltage is what? Minus 53.13. Current leads voltage by 53.13 degrees. Clear? Therefore, next phase current, phase voltage of Y phase, that is 20 at an angle 0, 10 at an angle, this is minus 120. Directly we can write 200 at an angle minus 120 minus 153. What is the value? 200 minus 173.13 amperes, volts, right? Volts. Like that, the phase voltage of B phase, that is 200, which is equals to 66 or minus 240 minus 53.13. So we have completed phase voltages. We all know that the phase voltage of star connected load are same as the line or phase voltage of delta connected supply system. Star connected load are same as line, which is equals to phase voltage of delta connected supply system. That's it. Therefore we have to get line voltages now. Line voltages, that is, we know that VL leads P phase by how many angles? 30 degrees, right? Therefore line voltage is what? between R and Y, which is nothing but VRY, which is root 3 times of VR, right? At an angle plus 30, which is equals to root 3. What is VR? 200 at an angle minus 53.13 plus 30, which is equals to what? 346.4 at an angle minus 23.13 volts. Like that, V by B, which is equals to what? 346.4, just we have minus 143.13, that is minus 173.13 plus 30. Like that, BBR, which is equals to what? 346.4, 66.87 plus 30, that is 96.87 volts. That's it. So we have phase voltages, line voltages, and phase currents, right? Which is nothing but line currents. Therefore, phasor diagram. Simple. First we have to draw phase quantity, right? VR, then Py, then Vb. Completed. Next, what is IR? Which leads phase voltage by 53.13 degrees, right? Here I am providing only one phase, IR only, that is phi, which is equals to 53.13, right? Next, what about VR by line current, which is present between VR and minus Vy, right? So which is always ahead by 30 degrees of this phase voltage. This is VRY. We all know that. What is this angle? This is 30 degrees, right? So what is the phase angle between line current and line voltage? What is this angle? What is this angle? Which is equals to what? 23.13. That is, here the current leads, means 30 minus 5, but here the phase angle is more than 30 degrees. This is the important note point of capacitive load, right? That is where power factor is leading power factor, that is I phase leads P phase by 5, which is equals to 53.12, right? We know that for leading power factor, the angle between line voltage and line current is, that is the angle between VRY and IR is nothing but phi minus 30. Why it is phi minus 30? Since phi is more than 30. This is the important note point, right? Phi minus 30. Therefore, the angle between VRY and IR is nothing but phi minus 30, which is equals to 53.13 minus 30, which is equals to what? 23.13. Satisfied? Prove. 23.13. The angle between line voltage and line current is 23.13. So we can justify that statement with respect to phasor diagram. This is the analysis of delta connected supply and star connected load.